Hello, this is mine for the video questions. For 2A, I just wrote it down. So nitrogen monoxide written right there. Hydrogen gas is H2 because it's diatomic. Nitrogen gas is also diatomic, which makes water vapor. That's why the state is gas. And then I balanced it, but nitrogen monoxide right there, pretty easy to see, I guess. And for B, 2B, it said they're all aqueous. So magnesium chloride, and then potassium phosphate, and then I just wrote the reaction. Magnesium phosphate and then potassium chloride are the products of that, all aqueous. It's cool. And I balance it out using this method. There's a 3 there, there's a 2 there, there's a 6 right there. That's question 2. For question 5, explain which one's statements are right. So statement B and C are the only ones that make sense, because C is like the actual equation with the correct amount of moles. Like, you take 1 mole of methane, 2 moles of O2 and react them. React them. Oh, and you produce 1 mole of CO2 and 2 moles of water. That's just like, it's like the conversion statement, like the actual thing. So C is right. B is the same thing. It's just like it's just a proportion of it. Like multiplied this by 5 and this by 5. This would be 5 and 10 moles, and this would be 5 and 10 moles. It's the same proportion. So B also works. The thing that doesn't work is A and D, because you can't go, it's not the same as using moles as like what's intended. Like grams won't work. You need to go from, or I guess you can get the molar mass, or it wouldn't get you to that area. And the same with molecules. Like, you go from molecules to Avogadro's number to back to moles. It wouldn't work out to what it's trying to state. So A and D are false. 6, what's being oxidized? It's the Leo-Gur, so loose. Electrons oxidized, and so the SN only needed to be a 2+ here, because this would be -4 and the thing is 2+, or 2 negative, so it needs to be 2 negative overall, so 2+, and then it jumped up to +4, so it lost electrons, the same thing, or vice versa for this phosphorus, or this P. It was just neutral, and it went to having a -3 charge, and so it got reduced, gaining electrons, reduced, and so the oxidized element would be the reducing agent, and the reduced element would be the oxidizing agent, and that's just how I go. Yeah, need -3 to balance out right there. Didn't explain that, but yeah. For 7, if it's soluble in water, MgOH is not a strong base, and so most metals don't dissolve in water. And, MgOH is an exception, so that's insoluble. NH4SO4 is soluble. It's just, I don't know, I know NH4 is really soluble in water. And I'm pretty sure sulfate is as well. Let me fact check that. Solubility check. There's NH4. Yeah, sulfate also is soluble, so that's mad soluble. And then, so B is soluble, A is insoluble, B is soluble. C, bromide usually is very soluble, but one of the exceptions would be lead, as shown right there. C, bromide, but the exception is lead, so that is not soluble. And for 8B, I wrote it out, you know, the hydrobromic, where is it? Oh, hydrobromic acid, the nickel carbonate, and I wrote the equation for it, and I balanced it, the 2 there, and so this would disassociate because it's a strong acid. This does not disassociate because that is not soluble because of carbonate, which is right there. It's soluble, you know, the vibes. So it's not soluble. That is not soluble, but you can like take it and turn it into a H2O plus CO2. So it's a gas. This is a gas reacting. Yeah, gas reacting equation, I guess. This is soluble because of bromide, and yeah, nickel isn't. Yeah, it's soluble. So that's fine. So I wrote it out. There's the bromide, and the hydrogen. Here's the nickel carbonate. And here's this. I just split it. H2O, CO2, liquid gas. I split this, and the bromides canceled out. So I had 2 H positive, 2 hydrogen ions, nickel carbonate, solid, H2O, CO2 gas, and nickel aqueous. And that is the equation that I came to. Yep.